Hello, my dear students, and welcome to the new lesson. In this lesson, we are going to learn about the bitwise operators. So, as its name suggests, this type of operators actually works on the data at the bit level. So, you might be knowing the word bit. So, bit is actually the smallest memory unit, and which is the digits 0 and 1. So, these digits 0 and 1 are called as the bits, and these operator works on the bits, that is zeros and ones. So, we will be using this bitwise operators on the integer numbers. So, that integer number will first be converted to the binary format. जो नंबर पे हम ऑपरेशन परफॉर्म करेंगे वो नंबर, वो इंटीजर नंबर पहले बाइनरी में कन्वर्ट होगा, एंड आफ्टर दैट दिस ऑपरेशंस विल बी कैरिड आउट. So we will see all these operators with example in this lesson. So this is the first operator, which is called which is a symbol tied, and it is used for doing the complement or the NOT operation of bits. So this operator is called as the bitwise complement operator. After that, ampersand, so which is the bitwise AND operator. So we have used AND before this also in the logical operators. So but there were two ampersand. So this is a single ampersand which is used to do the bitwise AND operation. So similarly, this is a pipe symbol, one pipe symbol, which is bitwise OR. Then this is a caret symbol, which is used for EXOR operation, bitwise EXOR operation, and this 2 times less than symbol. So this operator is the left shift operator, and 2 times greater than symbol is the right shift operator. So we will be using, or we will be learning all these operators in details in this lesson. So before going directly with the bitwise operations, we will firstly see the truth table for bitwise operations which we will be requiring for doing the bitwise operations. So this truth table will give you the result for the different bitwise operators like complement operator, AND operator, OR operator, and the EXOR operator. So let us consider the first operator, which is the complement operator. So from this truth table, it is clear that this operator don't have the left operand. So that means this operator works on a single operand, and therefore this is a unary operator. So complement operation is the unary operation. So in this operation, while doing complement of 1 will give you result 0, and complement of 0 will give you result 1. So it is a simple operation which is similar to the NOT operator. So let us see the next operator, which is the AND operator. So in the AND operator, output will be 1 only if both the operands are 1. That is, only 1 and 1 equals to 1, or otherwise in other cases output will be, or result will be 0. That means 1 and 0 will be 0, 0 and 1 will also be equals to 0, and 0 and 0 will be equals to 0. So this was the AND operation. Then next see the OR operation, or this is the OR operator. So in OR operator, result will be 0 only if both the operands are 0, or otherwise, or in other cases output will be equals to 1. That is, 1 or 1 equals to 1, 1 or 0 equals to 1, and 0 or 1 is also equals to 1, and 0 or 0 is equals to 0. So let us see the next operation, which is a EXOR operation. So from the truth table, if you can observe here, If both the operands are same, then result is 0. That is 1 XOR 1 is 0. Similarly, 0 XOR 0 is also equals to 0. And if both the operands are different, then result will be 1. That is 1 XOR 0 is 1 and 0 XOR 1 is equals to 1. So this is about the result of the bitwise operators, which we will be requiring for doing the bitwise operations in our next slides. So let us see the different bitwise operations. So firstly we will see the bitwise AND operation, and for example here we will be doing the AND of numbers 18 and 15. So let us see how this 18 and 15 will be done. So this is the binary representation of decimal integer number, which is 18. So if you don't know how this binary number is represented in decimal, so let us see this. So these are the place values in the binary number system. So this is 2 raised to the power 0, that is 1. This is 2 raised to the power 1, that is 2. This is 2 square, 2 cube, 2 raised to the power 4, 2 raised to the power 5, 2 raised to the power 6 and 2 raised to the power 7. So this is for the 8 bits. So to convert any binary number into the decimal number, you just have to add the place values where there is 1 in the binary number. जहां पे भी बाइनरी नंबर में 1 है, उन प्लेस वैल्यूज को सिर्फ आपको ऐड करना होता है, तो आपको मिलेगा इंटीजर नंबर, डेसिमल नंबर. सो दैट मीन्स टू कन्वर्ट दिस बाइनरी नंबर यू हैव टू ऐड 2 एंड 16, क्योंकि यहाँ पे 1 है. सो जहां पे 1 है वही की प्लेस वैल्यू आपको ऐड करनी है. So this is equals to 16 and this is 2. So that means 16 plus 2. So this number will be equals to 18. So similarly दूसरा नंबर देखिए, दूसरे नंबर में you have to add 1, after that 2, after that 4 and 8. So आपको ऐड करना है 8 plus 4 plus 2 plus 1, because there are 1 in these places, so which is equals to 15. So these are the two numbers, that is 18 and 15, and now AND operation of these numbers will be done. So you know the truth table for AND. So according to truth table, 0 and 1 equals to 0, 1 and 1 equals to 1. So 0 and 1 equals to 0. Again 0 and 1 is 0. 1 and 0 is 0. And after that 0 and 0 is equals to 0. Hence this will be the result of 18 and 15, and which is equals to value 2 only, because there is only 1 here, so which is equals to 2. So hence the result of 18 and 15 equals to 2 in integer. So let us consider the second operation, which is the bitwise OR operation. So we will be taking the same two numbers, that is 18 and 15. So now you know how this number are calculated, और how this binary number is represented 18 and 15. So अब आपको directly हम OR करते हैं यहाँ पे. So you know the truth table of OR. So therefore 0 or 1 will be equals to 1. 1 or 1 equals to 1. 0 or 1 is 1. 0 or 1 is 1. 1 or 0 is again 1. And after that 0 or 0 will be equals to 0. So hence the OR operation of 18 or 15 will be equals to 1 1 1 1 1, which will be equals to 1 plus 2 plus 4 plus 8 plus 16, and which is equals to 31. So this is how the OR operation is done. So if you know the truth table, then you can easily calculate any AND or XOR operation. So let us see the next operation, which is the EXOR operation. So this is the EXOR operation. We are using the same two numbers here, 18 and 15. So let us do the EXOR. So according to the truth table of EXOR, 0 XOR 1 equals to 1. 1 XOR 1 is equals to 0. 0 XOR 1 is 1. 0 XOR 1 is 1. 1 XOR 0 is 1. And after that 0 XOR 0 will be equals to 0. And hence the result of this XOR will be equals to 29, which is equals to 1 plus 4 plus 8 plus 16. So you just have to add the values, place values in this position. So which will be equals to 29. So this is how the different bitwise operations done in. So let us consider the next bitwise operation, which is a bitwise NOT operation. So let us consider the example 128 for doing the NOT operation. That means we have to calculate the NOT of 128. So this is the binary representation of the number 128. So in 16-bit compilers, to store any integer value, it requires 16 bits, out of which 15 bits are used to store the value and a 1 bit is required to store the sign. So this 128 will be stored in 15 bits. So in last examples also, in the examples of AND operation, OR operation and XOR operation, so to store the value 15 and 18, there also it requires 15 bits to store. But as there were zeros on left hand side, which will not change the result, so hence I have skipped that numbers in the last examples. But in case of NOT operation, NOT of 0 will be equals to 1, which will change the answer for 0 input. So hence we have to keep the numbers, left hand side numbers as zeros. So let us do the NOT operation. So here NOT of 0 is 1. So similarly NOT of 0 is here 1. So here also 1, 1, 1, 1, 1. So here NOT of 1 will be equals to 0. So NOT of 0 equals to 1, 1, here also 1, here also 1, 1, 1 and 1. So this is the NOT operation for the number 128, and which will be equals to 65407. So you can make the calculation for this number. You now know how the binary numbers are calculated or it is converted into the decimal number. So make the calculations here. So you can see that. So this number is equals to 65407. So this is how the NOT operation is done. So next type of operation is the bitwise left shift operation. So as this name suggests, this left shift operator shifts the number of bits to the left sides. So this operation shifts bits to the left hand side. Its syntax is like this: operand which you want to shift, and this n is the number of bits by which you want to shift. For example here, so consider the number 18 and we have to shift 18, left shift by 1. So let us see how this 18 will be shifted by 1. So for shifting each digit or each bit, you have to shift left by 1. So that means this 0 will be shifted here. This 1 will be shifted here. This 0 will be shifted here. This 0 will be shifted here, and so on. Each bit will be left shift by 1. So similarly this 0 will be shifted here, and so on. And a 0 will be added on the right hand side. So hence this will be the result for 18 left shift 1, and which will be equals to value 36. So very simple operation is here, that is the left shift operation. So let us consider the next operation, which is the bitwise OR operation, bitwise right shift operation. So as its name suggests, this is operator that shifts the number of bits to the right side. So its syntax is like this: operand which you want to shift, after that right shift operator and the number by which you want to shift. So for example, here consider the same number, that is 18. So we have to shift 18 right shift by 1. So let us right shift the number 18 by 1. So if you shift right by 1, so that means this number, this 0 will be deleted. This 1 will be shifted here. 0 will be shifted by 1 bit, right by 1. This 0 will be here. 1 by 1 here, and so on. So every bit will be shifted to right by 1, and lastly this 0 will be added on the left hand side. So hence this is the result for the operation 18 right shift 1, and which will be equals to, this number will be equals to 9. So this is how all the bitwise operations are done in C language. So let's have a look at simple program for the bitwise operators. So here in this program I have taken the same examples which I have discussed earlier in this lesson. So this is the program for printing the output of AND operation, similarly OR operation, EXOR, complement, left shift and right shift operator. So actually I have taken all these examples. So same examples I have written in this program. So let us run this program. So this is the output generated by the program. So first output is 2, which is by the 18 and 15. So output of 18 and 15 is here 2. Similarly, output of 18 or 15 is here 31. Output of 18 XOR 15 is 29. Then complement of 128 here is this value, because I am running this program on the 32-bit compiler, and in 32-bit compiler integer value is stored in 32 bits. So that's why I have this output of this is the complement of 128 is different than I have discussed. So if I run the same program on 16-bit compiler, then output for this complement 128 will be different. So we will be running the same program on 16-bit also. So then we will see the output for this complement 128 on 16-bit. Then 18 left shift 1 is value 36, and 18 right shift 1 value will be equals to 9. So rest of the output is similar on 16-bit machine and the 32-bit machine. So only difference is in terms of complement. So let us run the same program on 16-bit machine also. So this is the program. So I will run this program on 16-bit compiler. So see here, the output of complement. So the output of complement of 128 now is 65407, and rest of the output is same on 16-bit also. So only difference is the complement of 128. So this is the output of complement 128, that is 65407 on 16-bit compilers. So this is all for now. In the next lesson we will be coming up with new learnings. Thank you.